Hello, this is Mr. Stansbury. I'm going to take you through the notes on transforming exponential functions. At the end of this, you should be able to say, I can graph transformations of exponential functions. Okay, so we can use the transformations to graph functions of the form y equals b to the x. Okay, so here's like a general form for the transformations. Whatever's out in front here of the our multiplier b is going to be our vertical stretching or shrinking. Okay, this x minus c, this power up here, is going to be our horizontal translation, and then this d over here is going to be our vertical translation. And then there will also be a horizontal asymptote at y equals d, most likely on that. Okay, so there's not a single parent graph for all the exponential functions. Okay, instead there are parent graphs for each base b. Okay, so for example, graph f of x equals -2 times 3 to the x minus 1 all minus 4 and its parent graph. So really what we want to do first here is probably do the parent graph, and then after that we'll state domain and range. Domain and range. So parent graph, parent, and again, the idea behind a parent graph is like, what does this graph start from before it starts shifting? That's what a parent graph is called. Okay, so our parent graph is just going to be, we're getting rid of the a, the c, and the d. It's basically just y equals whatever our base is to x. So our base in this case is 3. So we're gonna we want to graph f of x equals 3 to the x. Okay. So our steps here are, we're going to find 3 points of the parent graph. Usually you want to do -1, 0, and 1. And then usually it's actually probably pretty good idea to find some more, depending on what the graph looks like. Usually more to the right will give you a little bit more information potentially. So we'll take a look at that. So find 3 points of paragraph. So if we plug in -1 for this here, so we get f of officially -1 equals 3 to the -1st. Now anything to the -1st power is just take that -1st power and you move it down to the bottom in the denominator here and turn it into a +1. So that's going to be 1/3. So -1 is at 1/3. If we plug in 0, that's 3 to the 0 power. Anything to the 0 power just equals 1. Okay. And then if we do f of 1, the first power, 3 to the first power, ends up getting just 3. So here's 3 points of our parent graph that we can do. So let's do those. So at -1, we're at 1/3. Oops. There we go. -1's at 1/3. 0 is at 1. And 1 is at 3. So you kind of get an idea. It's going up like this. Probably don't need to put any more over there. And guess what? There's plus, basically this is +0, so that means there's an asymptote here at 0. Right there. That line's not going to cross, so this graph is going to look something like, oops, missed it. Let's try that again. Oh, missed it again. Just got to take my time. Roughly-ish like that. It should go up a little bit straighter than that, but you get the idea. So there's roughly what our parent graph looks like. Okay. Now we are going to transform the coordinates using the order of operations. Okay. So now in this case here, order operations up here is going to be the exponent first, then the multiplying, and then the addition subtraction. So that's why I said horizontal is our first switch, and then stretching and shrinking is next, and then vertical comes in after that. Okay, so what it is just recopied down all of our parent graph points, those 3 here, and then we're going to do first horizontal, then we're going to do stretch and shrink, and then vertical. Now the horizontal is with this x minus 1 right here, right? So notice this is an x. So what we're going to do is we're going to affect the x. So we have x minus 1. Remember, anything that's ever attached to the x, we always do the opposite. So, or think of what's going to make this equal to 0. So what we're going to do is we're going to add 1 to all the x's. Okay? So that gives us negative 1 and 1 is 0, and then 1/3. 0 plus 1 is 1 and 1. And then 1 plus 1 is 2 and 3. Okay, so we've done the horizontal transformation. Next thing we're going to do is we're going to stretch and shrink. So that's dealing with this negative 2 right here. So that affects our y. So these two here and the vertical is going to deal with the y. The horizontal is going to deal with the x because it has the x with it. That's how I remember that. Okay, so that means we're going to multiply all our y's by negative 2. Okay, so we get 0, and then 1/3 times negative 2 is negative 2/3. 1 stays the same for the x, and then y1 times negative 2 is negative 2. And then the x stays the same there, and 3 times negative 2 is negative 6. Okay, so now we've done the stretching and shrinking. And then now the vertical, we're going to move all the y's. We're going to move all the points down 4. So we're going to subtract 4 from all these y's here. And let's put our answer up here so we can see it. So we've got 0, and then negative 2/3 and negative 4 is negative 4 and 2/3. 1, and then we negative 2 and negative 6 is 1 and negative 6. And then 2, negative 6 and negative 4 is at 2 and negative 10. Okay, so then now we can graph these points here. So at 0, we are at negative 4 and 2/3. At 1, we're at negative 6. And at 2, we're at negative 10. So we know that there's an asymptote at negative 4, right? So we draw our little asymptote line in there. So then we know that this graph is going to look something. Oh, that's bad. That's worse. Still not good. I'll get there. There we go. That's close enough. Okay, so then now we know that's what our new graph looks like. Okay. Now, what we can do is you can actually check that in the calculator that we have here, and basically just plugged all this thing in here. We'll push enter and start. I guess we could start at negative 1. That's not going to be too bad. And then step, go up by 1 each time. That sounds good. So negative 1 gives us something weird. 0 is negative. It's not weird. It's just not a nice number here. So negative 14/3 is going to be negative 4 and 2/3. And then at 1, we're at negative 6. And then at 2, we're at negative 10. So there's our 3 points that way as well. You can find those on the calculator. Okay. And then the last part here says find the domain and range. So domain, if you'll remember, is pretty much going to be what the x's can be. We can plug in any number here, so all real numbers. And then the range for this thing is what's the lowest it can ever go. It doesn't have a lowest, but it does have a highest. So the highest it ever is going to be is at negative 4. And we'll always put a less than sign here, so we know that y is going to end up being less than negative 4 for the range. Okay? Okay, we're going to do one more example, but before we do that, let's do a quick comedy break.